Alright, the first question, we just need to find the general solution. Now, if you have a trigonometric equation like this, tan x equal to tan 2x minus 25 degrees, you can't use a calculator now for this question, right? Like you can't use a calculator because the reference angle is already there. And that reference angle for our question here is going to be 2x minus 25 degrees. Now, because on the left we have got this x, on the right we have got 2x minus 25, it will seem like the x on the left is equivalent to the 2x minus 25 degrees on the right. So all you have to do is just introduce the k plus 180 degrees. Okay, remember the general solution for tan is shift tan of a ratio plus k times 3 times k times 180 degrees. Now for this question, this shift tan of a, it is already there. It will be like that one there. So all you have to do is drop this tan, drop that tan, and write it as x equal to 2x minus 25 degrees plus k times 180 degrees, where k is the integer. Okay? Then we solve it now. If we solve this, we take the 2x to the left, we get minus x minus 2x equal to minus 25 degrees plus k times 180, where k is an integer. And this will give us minus 3x equal to minus 25 plus k times 180 degrees, where k is an integer. Right? Then from there, we divide both sides by 3. So if you divide both sides by 3, you get this. By minus 3 rather. So you end up having x equal to 25 over 3, 25 degrees over 3 plus k times 60 degrees, where k is an integer. So the final answer, since we are not supposed to use the calculator, the final answer we can write it as x equal to 25 degrees over 3 plus k times 60 degrees, where k is an integer. So we're not supposed to use the calculator, so we can stop there. Right? If you want to divide the 25 by 3, to be fine, but you can leave it like that because you're not supposed to use a calculator. Right? So this is the first one. Then the second one is cos 2x minus 25 degrees. So let me start on a new page. So number 5 will be cos 2x minus 25 degrees equal to cos 38 minus x equal to cos 38 degrees minus x. And here our x must be between minus 90 degrees and 180 degrees. Which means we have to find the general solution first, then use it to determine all the values between minus 90 and 90 degrees. Okay? So I'm going to do the same as I did the equation for tan. Since We don't have a ratio here. We have got a specific angle, and here too. We just equate those angles, and then we bring in the general solution for cos. So our reference angle is going to be that 38 minus x. So we drop the cos on both sides, and then we end up having you end up having 2x minus 25 degrees equal to plus or minus. The plus or minus is based on the general solution for cos. This will be times plus or minus 38 degrees minus x plus k times 360, where k is an integer. Then to solve this now, we have to separate the two equations because of that plus or minus. So let me consider the positive first. If I consider the positive first, I have 2x minus 25 degrees equal to 38 degrees minus x plus k times 360, where k is an integer. Right? Then I'll take the minus x to the left, I'll get 3x, take the minus 25 to the right, I'll get 63 degrees plus k times 360, where k is an integer. Then we divide both sides by 3, we get x equal to 21 degrees plus k times 120, where k is an element of integer. So this will be the first general solution. Okay? We can use it straight away to determine all the possible values of x. Okay? We can use it to determine all the possible values of x. Right? Since our values are supposed between minus 90 and 180, if I substitute k equal to 0, right, when k is 0, x will be 21 degrees, which is correct. So this value here, it is between minus 90 and 180. If I substitute when k is 1, right, if I put k equal to 1, I'll get x equal to 141 degrees, which is also within this interval. Right? If I substitute k in this case, if I try k equal to minus 1, I'll get a value outside the interval. If I substitute k equal to 2, I'll get a value outside the interval. So it's only k equal to 0 and k equal to 1 for the first general solution. The second general solution, I have to consider the negative of those two. So that's what I'm going to do on the next page. Right, before so the second one is going to be 2x minus 25 degrees equal to minus. Now this one here, you put the minus, then you put the 38 degrees minus x inside brackets plus k times 360 degrees. Right? Remember, our x is supposed to be between minus 90 and 180 degrees. Already we found two values. Right? So this will become 2x minus 25 equal to minus 38 degrees plus x plus k times 360, where k is an element of z. Alright? So if I solve this, take the x to the left, we get x on the left. Then if I take the minus 25, I end up getting minus 13 degrees plus k times 360 degrees. Right? So this will be my second general solution. So let me use it to determine the value of x within that interval. So when k is 0, x will be minus 13 degrees. And that minus 13 degrees is in this interval. Right? Then, when k, if I put k equal to 1, I'll get a value of this outside. If I put k, any other value of k, I'll get a value of it outside. Therefore, my x values are going to be, x will be equal to minus 13 degrees and 21 and 141. 21 degrees and 141 degrees. Right. These will be my 3 answers for that question. Right. Any question there? If I do the last one for this exercise. Right. The last one is sine now, x plus 10 and 50 plus 2x. X plus 10 and 50 plus 2x. So it will be sine x plus 10 degrees is equal to sine 50 degrees plus 2x. Right, we just need to find the general solution here. Right, so here you treat this 50 plus 2x as your reference angle. So we end up having to drop those two, that is the sine. So we end up having x plus 10 degrees equal to 50 degrees plus 2x plus k times 360, where k is an integer. Now, this reference angle caters for the first general solution. Sine has got 2 general solutions. So if I simplify here, I'll get minus x equal to 40 degrees plus k times 360, where k is an element of z. Then I have to divide by minus 1, because the coefficient here is negative. So I'll get x equal to minus 40 degrees minus k times 360 degrees, where k is an integer. Right? So I found the first general solution. The second one, I have to subtract this angle here from 180 degrees. So I'll say, or x plus 10 degrees is equal to 180 minus 50 degrees plus 2x plus k times 360 degrees, where k is an integer. So this will give me x plus 10 degrees equal to, if I subtract here, I'll get 130 degrees minus 2x plus k times 360, where k is an integer. Then, if I check the minus 2x, this minus 2x to the left, I'll get 3x, and then take this positive 10 to the right, I'll get 120 plus k times 360, where k is an integer. So my final answer, if I divide by 3, I'll get x equal to 40 degrees plus k times 120 degrees, where k is an integer. So this will be my second general solution. Right? So that's how you can do. Some questions, they require you to use co-ratios. If, say, you've got sine on one side and cos on the other side, you may need to use co-ratios and then apply your knowledge of the general solution. All right?